Hi guys, today we are going to look at derivative rules of product and quotient, but before we begin, I would like you to try the warm-up. So hit pause on the video and see if you can come up with the derivative. All right, we haven't talked about product and quotient yet, although you may remember it from last year, but the first thing you should really be asking yourself about this is that is there any way to make this function easier? Is there any way to make this easier before I take the derivative? Okay, so let's look at that. So if I look at this problem, I see that x squared can go into everything in here. So I could rewrite this problem as f of x equals x cubed minus 2x squared plus 7x. That's certainly easier than dealing with a quotient rule. So anytime you're given that opportunity, don't automatically jump to the rules. Look to see if you can simplify it first. And so then when I go to take the derivative of this, I get 3x squared minus 4x plus 7. If you were to have used the quotient rule rather than trying to simplify this first, you should have come up with the same answer. It just probably would have required more simplification. Okay, what I would like you to do now is try the particle motion practice. And you can see that the graph is on here if you happen to get one of the sheets that didn't have the diagram in class. So hit pause and try this particle motion problem. All right, a few things to point out in this particle motion problem. One, this says that the graph shows the velocity. That's important. Just keep in mind what the graph actually represents of a particle in feet per second moving along a horizontal line for t is between 0 and 6 seconds. And then it says on what open intervals or at what times from 0 is less than t is less than 6 is the particle at rest, and then justify your answer. So what does it mean to be at rest? Well, we know that if a particle is at rest, that the velocity is 0. So do I need to do anything different with this graph at all? And the answer is no. I have this graph. I can see where it's equal to 0, and I can see that it is when t equals 1. As well as when t equals, 4.2. Okay, then it says on what open intervals between 0 and 6 is the particle moving to the right? What does that mean? What does it mean to be moving to the right? Well, it means that the velocity is greater than 0. So where is the velocity greater than 0? Well, we can see that it's greater than 0 here. And we can see that it's greater than 0 here. So let's go and write an interval notation for that, the interval notation. And it's going to be from 0 to 1 with 4.2 to 6. So notice we have those places where it's at rest is where it's changing from moving to the right. Our justification would just be this is where the velocity is greater than 0, which is what we wrote. Then it says on what open intervals, or at what time is the particle speed increasing? Okay, let's review what it means to be the increasing speed. Remember, if we're going to be increasing, let's do this. Green means go. If we are going to be increasing, then I know that my velocity and acceleration need to agree. I'm just going to put they must agree. So they either both need to be greater than 0 or they need to both be less than 0. Well, we haven't really looked at the acceleration at all. So let's talk about the acceleration here. Remember, acceleration is the derivative of the velocity. So we're really looking at the value of the slopes. So let's talk about the value of the slopes where they agree. If we look at the velocity, let's start with negative velocity. we have negative velocity from 1 to 4.2 is where the velocity is negative. So anywhere in there where the slope of the graph is also negative, we know that that will be a place where the speed is increasing. So if I look through there, the place where the slope and the velocity are both negative would be, I'm going to write increasing here. That would be from 1 to 3 is the only place where it's negative, negative. So now let's look where the slope is positive as well as the velocity being positive. Well, the velocity is positive in these highlighted yellow sections. And so the place where the slope is positive here is from 4.2 to 5. So I'm going to put that as my increasing as well. So from 4.2 to 5. Okay, so let's talk decreasing. So where is the particle speed decreasing? Well, if it's decreasing, remember that the V of t, and A of t do not agree. Okay, so the place where they do not agree, we need a positive and a negative or a negative and a positive. So the place where the velocity is positive but the slope is negative is from use the x values, is from 0 to 1. Okay, so from 0 to 1, my slope is negative, but my velocity is positive. So 0 to 1. And any other place that it doesn't agree, well, down here, my slope is positive, but my velocity is negative. And that would be the other place where this would be decreasing, would be from 3 to 4.2. Probably we could have used process of elimination from what we already got from increasing to find decreasing, but there you have it. All right, the last part says, what is the particle's velocity? No, it doesn't. It says, what is the particle's acceleration at t equals 4.8 seconds? And explain what this means in terms of the particle's velocity. Well, if we look at the acceleration at 4.8, we are looking for the slope at 4.8. Well, the slope at 4.8 is somewhere right in here, and this slope happens to be a straight line, and it starts at 3 and goes up 10 over 2. So this slope would be up 10 over 2. And so then this would be the acceleration would be in 5 feet per second squared. Okay, feet per second, so feet per second squared. So what does it mean in terms of the particle's velocity? Well, at that moment, at 4.8, the particle's velocity is positive, so it's moving in the right direction, and the speed is increasing at that point, is what we found. So, how'd you do? All right, let's move on to the product and quotient rule. Okay, ideally these rules are review for you, so we're just going to go over them fairly quickly. If you need a more in-depth description about the derivative rules, please feel free to just search them through Google. You could probably find a Khan Academy that would explain them. We're going to go through them as if you have seen them and just reiterate some of the things that go along with them, with the rules. So the product rule says that if we're going to take the derivative with respect to x of two functions that are multiplied together, f of x times g of x, that this derivative is going to be the derivative of the first function multiplied by the second function plus, and you could see this written either way, but I'm going to write it, the derivative of the second function multiplied by the first function. Okay, there's the product rule. And then the quotient rule is the derivative with respect to x of two functions that are being divided is going to be the derivative of the top times the bottom minus the derivative of the bottom, or the denominator, times the top, the numerator. over the denominator squared. Okay, so let's look at a couple of examples. All right, this first one. The first thing you probably see is a product rule. So we are going to do product rule. I'm going to use this 3x squared minus 2 as my f of x. And then I'm going to use my 2x plus 3 as my g of x. So when I go to take the derivative of this whole function, f prime of x, it's going to be equal to the derivative of the first part, which is just 6x, times the second function, 2x plus 3, plus the derivative of the second part, and the derivative of the second part of 2x plus 3 is just 2, times the first. So this is what the product rule would look like. And of course, we're going to simplify. So we get f prime of x equals 12x squared plus 18x plus 6x squared minus 4. So combining all those, we get f prime of x, or the derivative of f with respect to x, is 18x squared plus 18x minus 4. Okay, so that's using the product rule. Now, it is possible, if we use algebra first, to get it the same answer. So we're going to look at that. So we're going to talk about using algebra first. What might that look like? Well, if I used algebra first, the first thing I'm going to do is rewrite what f of x equals. And multiplying those out, I would get that f of x equals 6x cubed plus 9x squared minus 4x minus 6. And now I can take the derivative here. And if I take the derivative with respect to x now, I get 18x squared plus 18x minus 4. Notice that it's the same regardless if I simplify it first or use the product rule. Most of the time, I will argue that it's easier to simplify first. On occasion, sometimes the product rule is simpler. It's really up to you as to whatever you think is going to be easier. So, let's try another one. Notice this next problem is a quotient rule where the numerator is going to be my f of x and my denominator, 2 minus 3x, is going to be my g of x. So if I go through to find the derivative here, we'll call this one dy dx. First thing I'm going to do is take the derivative of the top, and the derivative of the top would be 4x minus 4 times the derivative of the denominator, 2 minus 3x. In between there is going to be a minus. The derivative of the bottom, or the denominator, would be negative 3 times the top, or times the numerator, which gives me 2x squared minus 4x plus 3. All over 2 minus 3x squared. Okay, now we need to simplify this. So dy dx, the derivative of y with respect to x, is equal to, let's see, we get 8x minus 12x squared minus 8 plus 12x. Minus a negative 3 is going to be a positive 3, so I can distribute a positive 3 to get positive 6x squared minus 24x. It's a positive 3 times positive 3 is positive 9 over 2 minus 3x squared. Rarely will I try to multiply the denominator because it is possible that once the numerator gets completely simplified, there will be common factors. So I'm going to leave it in its factored form. So we get dy dx equals, that would be, combining like terms, we get negative 6x squared plus 8x plus 1 over 2 minus 3x squared. So on this one, nothing I can do to simplify it more than that. All right. Let's try another one. Okay, looking at this next example, hopefully what you notice is I wouldn't even use the quotient rule on this one. Certainly we can, but I think your best bet on this one would be to change it to be, I don't want it to say prime yet, y equals -9 over 5 x to the -2. Because then I can just use the power rule. So I can rewrite this to say y prime equals, well, that will end up being positive 18 over 5 x to the -3. So y prime equals 18 over 5x to the third. How'd you do? Certainly you could have used the quotient rule, but I think you'll see that rewriting it to make it a little bit easier before you begin is much simpler process. All right, last type of problem. Let's look at this last one. I would like you to hit pause, see what you can come up with. All right, if we look at this one, the first thing you should notice is that what we're trying to find is g prime of 2. But we know that g of x equals x squared times f of x. So the first thing we're going to do is we are going to take this problem and put it into the product rule. So if I rewrite this, I would have g prime of x equals the derivative of the first, which would be 2x, times the second, which is just f of x, plus the derivative of the second times the first. So if I do the derivative of the second times the first, we'd have something that looks like this. Well, now I'm going to use the fact that I'm trying to find g prime of 2. Since I'm trying to find g prime of 2, here is what I'm really looking at in this problem. G prime of 2 would be 2 times 2, f of 2 plus f prime of 2, 2 squared. So let's do the math that we can and substitute in with what we know from our problem. So we would get g prime of 2 would equal 4, and f of 2 we have up here is 3. So I'm going to multiply 4 times 3, plus the second part here says f prime of 2, and we have that information as well. So f prime of 2 would be -4 times 2 squared, which is 4. So g prime of 2 is equal to 12 minus 16, which would be -4. How'd you do? All right. Hopefully you remember the product and quotient rule. Your assignment tonight is on a web assign, so go ahead and get started.